answer will look like this. So at least I write the parentheses. Then I say, okay, I know the first term is the f term. First times first. So 1 times 1 makes x squared. Yes? X times x. So we put it in. I know it's kind of strange because we already know the answer, but it'll help us walk through it one time. Okay, then I look at the 6. Say, how did we get the 6? Do you think? How do you, yes?
Why do you skip the 5x?
I'll tell you in a minute.
Okay.
Why do we skip the 5x? I'll tell you in a minute. 6. Yes.
Well, if you figure out what you need to do to get the 6, then you already know what you need to do for the, like what you'll end up getting.
Yes, and if you figure out what you need for the 6, possibly you'll get what you need for 5.
Don't really worry about
Yeah, 6 is more, it's as sure as f is L, because f is what times what equals x squared, and L is what times what equals 6.
And O and I, you already have to add.
And O and I are going to add, yeah, we're going to write that soon. So 1 times 1 equals 6, 2 times 3, or 3 times 2, or 6 times 1, or 1 times 6. Alright, so keep that in the back of your mind. Think of all the numbers that multiply to 6, factors. Okay, so we tried 3 and 2. Try 3 and 2. Yes?
How do we know? We just know that it's addition because that's addition as well.
In this case, yeah, we know since these two are addition, these two will be addition.
What if it's 2 negatives?
We'll get to that. So for now, leave off the signs is what I'm saying. Leave off the signs in the learning process. Okay? And then we do a quick FOIL to check in our minds. So let's quickly FOIL this. So what do we got? X squared. Alright, what's the next term? 2x. Notice I'm not putting any signs.
3x.
X squared 2x. 3x. And 6. Okay. So, we look at this. We say, can we somehow, possibly, maybe, hopefully, combine 2x and 3x using addition or subtraction to make 5x?
Yeah.
We can. What do these?
Can you also do the diamond problems?
Diamond problem? That's a method. That is a method. It's fine.
Okay.
That's not how I'm going to teach it, but
Okay.
there are many other methods. Yeah. So for now, 2x and 3x add up to 5 if both are positive. So, if 2x is to be positive, wouldn't you agree that x needs to multiply by positive 2? So here's a plus sign. And if 3x needs to be positive, wouldn't you agree that positive 3 has to multiply with x? And then we confirm in the L of our FOIL, the last term, 3 times 2 is 6. These two combine to make 5x and we're done. So this is the answer, right? It was a simple example, but it walks through the process. Okay. We're going to try another one now. 4x squared. 20.
Should we leave that big gap?
I got you. Okay.
Are we ready to start? I have a question.
Yes.
So for this one, it kind of like has to do like kind of starting to solve the problem. Is that okay?
Yes.
Okay. So because 4 is in common with all of them, would 4 be on the outside?
4 is factored out, yes. 4 is the greatest common factor.
And that's factored out. So if there's a number that can be multiplied, you know what I mean?
Yeah.
Then it's on the outside?
Yeah. Yeah.
Okay.
So let's write it down. So 4 is the greatest greatest common factor. 4 comes out. Alright, yes.
And then you do x. And then, wait, do you do? Okay, so I know that you want to write the 2, so there's 2 there.
Would you agree that if you distribute it's that?
Yeah, but wait, do you do like the parentheses? Like, what?
Not yet.
Not yet? Yeah.
Step 1, greatest common factor.
Okay.
That and 2 parentheses.
Okay, then I can do 6 or minus 6.
Minus 6.
X. Then plus 5.
Plus 5.
Yeah.
Okay. Now we factored out the greatest common factor. And 4 is right here. Yep. Try this out. Put your F term in, the first.
Excellent.
The first, yeah, I'm going to give a little time for people to try. First here. So that's x and x, that's right. Okay. And then we look for L, which is the 5, yeah?
6 and 1.
5.
6 and 1 subtracted and stuff.
I have a, think of it in terms of multiplying.
3 and 2.
Multiplying to 5, yes.
5 and 1.
Yeah, multiplying to 5.
Multiplying is 5. Oh, right. Yeah.
The last problems we've done, look at your paper. It multiplies to this last term. It multiplies to the first term, it multiplies to the last term. Multiply. Multiply, L. And then add or subtract to 6x, negative 6x. So what multiplies to 5? We heard it, 5 and 1. 5. Alright, FOIL to check it. X squared. 1x, right? Stop.
Why did you write the word?
Yeah, x is fine.
Why is that?
I know, I'm being very formalized. X, and then 5x, and then 5. Okay. So, we did our F, we did our L. Add or subtract to get O and I. How do we combine these to make negative 6x? What do they need to be? Yeah.
Negative x and negative 5x?
Both need to be negative, correct. If both are negative, this needs to be negative to make negative x. This needs to be negative to make negative 5x. And then notice, negative 5 times negative 1 is plus 5. Amazing.
Okay, guys, we're going to work our practice problems. Again, Robert Adhoot is such a fabulous math teacher, in my opinion. I just wanted to let him teach this lesson, and then I'll do your practice problems with you. So we are factoring, and factoring trinomials. Factoring is probably the most important thing to know going forward in algebra. And again, that's why we stress when you're younger knowing your multiplication tables, because you cannot do this if you don't know these multiplication tables. Alright, so let's get started. Let's draw our 2 parentheses, and we know that the first 2 terms are going to be x times x. Then we're going to think about the factors of 42. Well, we've got 1 and 42. 2 and 21, 6 and 7, and of course all those could be reversed. Alright, so which of these 3 pairs do I think could end up giving me a negative 1? Well, obviously the 6 and the 7 are the only one that could possibly have a difference of 1. So that means that I'm going to have a 7 somewhere and a 6 somewhere. Now, I have to ask myself, if this is negative, that means that one of these has to be negative and one positive, because when you multiply, you've got to have one of each. to end up with a negative. The question then becomes, which one needs to be negative in order to add to a negative 1? Obviously, the 7 because it's larger. So I'm going to say x plus 6, x minus 7. Now some of you are going to say, does it matter the order? It doesn't matter. This would also be right. X minus 7 times x plus 6. That would be counted as correct. However, if you have x plus 7, x minus 6, that would be wrong. You cannot do that. The signs do matter. They have to be with the right number for it to end up correct. Okay, in B, we've got x squared plus, let's say, 1x minus 42. Well, we know we're going to use, because this is a 1, we're going to use 6 and 7 again. We're going to have x here and x here. One of these is going to be 6 and one is going to be 7. It doesn't matter which one you put where. But now, in this case, I need one of each, a negative and positive, to give me a negative 42. Which one needs to be positive to give me a positive 1x? The 7 needs to be positive. When I multiply this out, x times x is x squared. And then x times 7, I've got a 7x and a minus 6x and a negative 42. So that's how you check your work to make sure that you've got the right thing. So x squared plus x minus 42. And then we have the correct answer. Okay, and finally, x squared minus 6x minus 16, x and x. We've got negative here and negative here, so we're going to have to be really careful with our signs. 16, the factors of 16 are 1 and 16, 2 and 8, 4 and 4. Obviously, 2 and 8 are the only ones that are going to be able to give us 6. So let's do this. X squared, we're going to have a 2 here, an 8 here. So that would give us an 8x and a 2x, and then 2 times 8 is 16. Alright, for this to be negative 16, I have to have one of these as positive and one as negative. It doesn't matter which, except that it does matter because my middle term has to be negative 6. So obviously the higher number has to be negative and the lower positive. So if I check that, I've got negative 8 and positive 2 is negative 6x, and negative 8 times 2 is negative 16. So I can check my work in these problems and I know that I have the right answer. There's no excuse for ever missing one of these. Good job. I'll see you back next time for lesson 70.